you may press star 1. To withdraw your question, that is star 2. Please continue to stand by, and thank you for your patience.
Good afternoon. I'm Stephanie Shearholtz from NASA's Office of Communications. Thank you for joining us today following the flight readiness review for Boeing's Crew Flight Test to the International Space Station. Here to talk to us about the review and the upcoming mission are NASA Associate Administrator Jim Free, Ken Bowersox, Associate Administrator for NASA's Space Operations Mission Directorate at NASA headquarters, Stich, Manager of NASA's Commercial Crew Program, Dana Weigel, Manager of NASA's International Space Station Program, Emily Nelson, Chief Flight Director for the Flight Operations Directorate at Johnson Space Center, and Mark Nappi, Vice President and Program Manager at Boeing's Commercial Crew Program. Our speakers will each share brief opening remarks, then we will open the line for questions. You may enter the queue to ask a question at any time by pressing star 1 on your phone. To remove yourself from the queue, press star 2. We ask that you please stick to one question and identify to whom you are addressing your question. Please keep your questions focused on today's topic. To start, we'll begin with NASA Associate Administrator Jim Free.
Okay, good afternoon, everybody. On behalf of the Administrator and Deputy Administrator, I want to thank you for joining us this afternoon. Our teams have spent the last 2 days reviewing the readiness for the first crewed flight test of Boeing Starliner spacecraft to the International Space Station. I do want to thank the incredible NASA and Boeing teams who got us to today and participated in this review and all the reviews leading up to it. And I want to recognize and congratulate our new ISS Program Manager, Dana Weigel, on her first readiness review in this role. The first crewed flight of a new spacecraft is an absolutely critical milestone. The lives of our crew members, Suni Williams and Butch Wilmore, are at stake. We don't take that lightly at all. The most important thing we can do is protect those two people as well as our crew currently on board the space station. It's our collective job to ensure we can fly this mission successfully, and to do that, it must be safe. Safety has and always will be our primary core value at NASA, and it's our primary focus during this readiness review, all the reviews that have led up to it, and the entire development process. I can say with confidence that the teams have absolutely done their due diligence. There's still a little bit of closeout work to do, but we are on track for a launch at 10:34 Eastern Daylight Time on Monday, May 6th. I'll let others share more details of the mission, but I'd like to take a moment and zoom out a little bit. In human spaceflight, in U.S. human spaceflight, this will be only the 6th time NASA astronauts have flown a new spacecraft, and the first time a female astronaut, Suni Williams, flies the first crewed flight of a crewed spacecraft. I'm so glad Suni and Butch are on this flight. It was great. They flew in today. They flew over the building we're in here at KSC. They are an absolutely fantastic crew with extensive experience, and it's very clear that they know the spacecraft, the mission, and that they're ready to go. Let me just remind everybody again, this is a new spacecraft. I'll also remind you this is a test flight. We have the benefit of what's been learned on OFT-1 and OFT-2 certainly to help us out. It's part of NASA's fulfillment of our mission to explore the unknown in air and space, innovate for the benefit of humanity, and inspire the world through discovery. We certainly have some unknowns in this mission, things we expect to learn being a test mission. We may encounter things we don't expect, but our job now is to remain vigilant and keep looking for issues. We heard several people say that very eloquently today. I don't want to get too far ahead since we'll still need to fly a successful mission, but when we do and when we certify Starliner, the United States will have 2 unique human space transportations that provide critical redundancy for the ISS access. A new human spacecraft is an innovation, and that is inspiring to me and I'm sure to many others. The dissimilar redundancy, transportation redundancy to ISS has been an important part of our program plans since the award of the contract, and it's an important part of our safety going forward. NASA's partnership with American private industry is changing the arc of spaceflight history by opening access to space to more people, enabling more science that can only be conducted in the unique microgravity environment, and enabling more commercial opportunities. NASA has been at the forefront of this change, and I want to take a moment to acknowledge all the individuals and teams who led the way with commercial cargo to enable commercial crew, which has in turn enabled private astronaut missions and been a model to our commercial partnerships for Artemis. And also let me point out that there are many elements of this mission which have similarity to hardware that will fly on Orion, parachutes as an example. So this is important across our entire agency. It's been incredible in the last 10 years to watch the growth of new space fans who are closely following the development and testing of new spacecraft. I'm encouraged that these fans have gotten some practice watching these test flights. It's a good reminder for all of us. The team has practiced, run sims, run models, but there's nothing like flying in the space environment. As I mentioned earlier, we're going to learn from this mission, this test flight. I'm looking forward to us increasing our knowledge and understanding and proving a new spacecraft. I'm really proud of the teams. I'm proud of Ken Bowersox, Steve Stich, Mark Nappi, Dana, the entire team that's got us here. With that, let me turn it over to Ken.
Thanks, Jim. I'm really proud of our team, too. And thanks to everybody who dialed in. We hope we'll be able to share some information that you'll find of interest. You might hear a little bit of tiredness in my voice. The last couple of days has been a lot. We've looked at summaries of a huge amount of work by our whole team. And just thinking about it makes me realize just how valuable our team is and how important our people are to make sure we're ready to fly. We had the chance to talk about the launch vehicle, to talk about the Starliner spacecraft, and we've looked at summaries of the data from previous ground simulation testing and flight testing on the uncrewed vehicle. But now we've reached a point where we need to move forward and put crew on board the spacecraft. And that makes me excited, so I hope you hear that in my voice too. Butch and Suni joined us for the first part of the review. Butch reminded us how important it is to keep working thoroughly at a job all the way till you're finished. And Suni reminded us that launch dates aren't magical dates. The important thing is to launch when we're ready. I can tell you at this review, the team worked thoroughly through every bit of data that we had to look at as a management team, and I know that the teams that reviewed that data before it was brought to us looked at it even more closely. So when we polled today, the team polled go, and we decided that we are ready to move forward to the crew flight test. Again, May 6th is not a magical date. We'll launch when we're ready. And we're looking forward to when that occurs. Now I'd like to pass over to Steve for any other details that he might want to share about the review.
Yeah, thanks, Ken, and thanks to all the reporters for calling in today and for your interest in the Commercial Crew Program and human spaceflight. As Ken said, today was a huge day for our Commercial Crew Program, the ISS program. All the partners, the partnership, and then our whole team polled go to proceed to the launch on May 6th, which was a huge event. Not only that, but we did sign what we call an interim human rating for Starliner for this crewed flight test, which is our second interim human rating we've had in the Commercial Crew Program. So it was a huge deal for NASA and our entire team. You know, it's an important mission to go test out Starliner's capability. I think I've said many times OFT-2 was an important mission on the path to the crewed flight test. The crewed flight test is an important path on the way to certification of Starliner, the final certification, and then building a second transportation capability to transport our crews to and from the space station. So it's a huge goal of the Commercial Crew Program. We're also enabling a low Earth orbit economy, I think, with a second vehicle, which is huge for our nation and for the Commercial Crew Program. It really is pretty hard to put into words for me what today means. I've been on the Commercial Crew Program now 8.5 years. I've watched our team work diligently day by day, doing analysis, testing, reviewing certification products for both the United Launch Alliance Atlas V vehicle and Starliner, and that team has just done a fabulous job, and that's what gives me the confidence to proceed toward launch with Butch and Suni. The entire NASA, Boeing, and United Launch Alliance team and all the contractors have done a tremendous job working through a myriad of problems, getting the certification done, and getting us to this point today. I have a lot of confidence in this entire team. I trust this team. We had our program, Flight Readiness Review, last week, and all the elements polled go, and I could see how every single manager, every single engineer was ready to go and had done all they can to make this flight successful and to protect the crew, Butch and Suni. You know, we also in our program stand on the shoulders of many giants in NASA who built up this capability to have our human-rated vehicles. The road to CFT has been very thorough in terms of doing structural testing on the spacecraft many years ago, hot firing the thrusters, doing a pad abort test in 2019, testing the parachute system, OFT, the Orbital Flight Test 1 and 2, and then so many reviews, closure of anomalies from the flights, closure of all kinds of problems. So we've been side by side with the Boeing team this entire way and the United Launch Alliance team, and so we're really ready to move forward. It was great to see Butch and Suni today land and be down here and joining us. To me, it's when it gets serious. It's when the crew comes down to KSC for a launch. It means we're in the final phases of preparation. I have a lot of confidence in Butch and Suni. They've trained for years on this vehicle, on Starliner, been side by side with us. They know the vehicle inside and out, and they've been part of the test environment that's developed the Starliner capability. So overall, things are looking good for a launch. As Jim said, 10:34 p.m. Eastern on May 6th. Dana Weigel will talk a little bit about some of the visiting vehicle traffic that we have to get wrapped up to make sure that ISS is ready to receive Starliner. But overall, the vehicle processing is going well. I know Mark will talk more about that, but you know, we've had the United Launch Alliance Atlas V and Starliner in the vehicle integration facility out doing testing over the last few days. That's going really well. Mark will talk about a big activity we have tomorrow with the crew. And then in terms of open work, we just really have a couple standard things to go work on. Some pad work on the ULA side, replacement of a valve, and then some final analysis on for heat shield separation. We're excited to make history on this flight. You know, I don't take lightly that this is our second crew transportation system that we're bringing online in our program in the last 4 years. And as Jim said, we've had 6 of these in the history, and for 2 of them in the last 4 years is really a big first. This will be the first crewed launch from the Cape in 56 years. Apollo 7 was the last, the first launch of a crew on the Atlas V launch vehicle, and the first launch of astronauts on the Atlas family all the way back since Mercury in 1963. So we're excited for our Boeing colleagues and our United Launch Alliance colleagues. And really, it's the first time in history that we'll have enabled 3 spacecraft at the same time, ISS vehicle, the Dragon spacecraft, and Starliner as well. So it's a very proud moment for me. It's a proud moment for our team. I really want to thank our NASA team across the country, Boeing and all the contractors, and United Launch Alliance as well. For the comprehensive review, we'll take it step by step on the way to launch, and we'll be ready to go when all the elements are ready. And I'll turn it over to Dana.
All right, thank you, Steve, and thank you all for joining us today. As you've heard, it's a really critical milestone for all of us, and we're really excited to have Butch and Suni on board the International Space Station pretty soon. As Jim Free mentioned, having redundant crew vehicle capability from the U.S. To transport our crew to ISS is really important. It helps us with any number of different contingency scenarios that we can encounter, whether that's launching crew on board to keep us continually crewed, or issues we could face on board with other spacecraft that require redundant capability for crew rescue purposes. You heard a lot about today's review. From my standpoint, it was very thorough, very complete. No rock was left unturned. I was really happy to see that. On the station side, we still have a few things that we need to do on board station to get in the right configuration to accept CFT, but we're not working any issues at all in the run-up to the flight. On board the vehicle, the crew is very busy. On the USOS side, the crew is closing out our SpaceX 30 cargo and research mission. On the Russian segment, Oleg and Nikolai did a Roscosmos spacewalk today. They deployed a radiator system payload and installed some environmental experiments outside, so that spacewalk went well, no issues there. We do have a series of events on board that are in the critical path for Starliner's arrival. First up, we've got to undock SpaceX 30 from the Zenith port of Node 2 Harmony. That'll be no earlier than Sunday because we're chasing some bad weather over the next couple of days. The SpaceX 30 mission will return more than 4,000 pounds of science and research investigations. A couple of days after that SpaceX 30 undock, we'll plan to do a relocation of the SpaceX Crew 8 Dragon vehicle. That's going to go from the Node 2 forward port to the Zenith port, and that's going to free up that forward port for Starliner. After that, we've got some robotic activities to go inspect our forward port, and then we'll be ready to accept the CFT vehicle. That Starliner mission will be just a little under 2 weeks on board station. Butch and Suni will put Starliner through its paces, checking out the spacecraft, fit checking emergency equipment, and testing some of the operations that we're going to ultimately need for the longer duration missions that Starliner will have in the future. On the station side, we've intentionally cleared our flight plan, our vehicle traffic, and our schedule so that we've got a really large window to accommodate this CFT mission. So if for whatever reason we need more time for the mission, whether that's in the run-up to launch or on board, there's no issue at all accommodating a longer mission duration. We're very much looking forward to having Butch and Suni on board soon. Our team is ready to support this historic test flight, and with that, I will pass it to Emily Nelson.
Good afternoon. Thanks so much for your interest and for joining us today. This week's review has been the culmination of a detailed review season that has really thoroughly established that we are really ready to go on this flight. The NASA and Boeing teams have done a tremendous amount of work, and we're really excited to get to this point and looking forward to next week. You all very likely saw Butch and Suni arrive earlier today. They are so excited to be here. They expressed their gratitude to the CFT teams when they kicked off the readiness review yesterday, and coming up from here to launch. They are first going to participate in a mission rehearsal tomorrow. They'll suit up, head over to the vehicle integration facility, and get into the spacecraft using all the same procedures that they'll be using on launch day. Over the weekend, they're going to get some time off for rest, and then next week they'll have a couple of final briefings. They'll get some study time, and most importantly, they'll get time with their families before this important mission. The crew on ISS has had a really busy SpaceX 30 mission, so they're finishing that up once we get SpaceX 30 on the ground. As Dana mentioned, Matt, Mike, Jeanette, and Alexander are going to fly their Dragon from the forward point port to the Zenith port to make way for their Starliner arrival. The ISS crew is just so excited to have Butch and Suni on the way, and we plan to put the two of them to work. So with that, I will hand over to Mark Nappi.
Thank you, Emily. Just to recap where we are in this process, we flew OFT-2, which was the uncrewed flight test. This test is going to add crew, obviously. After a successful mission, we'll come back and we'll work on our final certification for Starliner 1. But right now, the focus is CFT. So where the vehicle's at today, we're in the final stages of prep with the launch vehicle and the spacecraft. The vehicle and spacecraft are at the vehicle integration facility. There's a little bit of forward work ahead of us. Most of this is all standard, but there's some cargo stow, a mission data load that will occur at L-3 days to give the last minute details of the weather and the prop loads, et cetera. There's some integrated testing, and then of course roll to the pad. Yesterday and today were obviously big days with completing the flight readiness review. There were a lot of reviews leading up to this, and really what I personally took away from it, and I heard a lot of people say, was that there's just total alignment amongst all the directorates, NASA, Boeing, ULA, and other contractors. And with that, we can conclude that there's a lot of confidence in the system. So we're ready to go. The team is really peaking. There's a practice tomorrow that Emily talked about with the mission dress rehearsal and the crew training activity. That'll be the last training activity for the crew and the team leading up to launch. Steve and I meet with the crew every 2 weeks, and you can really tell that they are ready for this. It's been really great conversations having with them ever since January when we came back and we started getting close to this milestone. We're going to execute for the next 10 days the launch preps, and then we're going to take it one phase at a time. The first phase is launch and orbital insertion. Second phase is to get to ISS and dock. Third phase is the docking operations. The fourth phase is undock and reentry, and the last phase is landing. So I'd like to really thank the team, ULA, our suppliers, the Boeing team, all past and present, and then a big thanks to NASA for all they've done to get us here. So back to you, Stephanie.
Okay, thank you to all of our opening speakers. Good words, good insight. Thank you for sharing. So we will now move to the questions. So if you have a question, please dial *1 to get in the queue. If your question was asked, you can remove yourself from the queue by pressing *2. Let's go ahead and get started. First question, I believe, comes from Chris Davenport.
Hi, thanks for doing this. My question's for Mark, looking ahead a little bit. In a conversation last year, John Shannon said that Boeing was having a hard time making Starliner into, quote, a positive business case, and that the future of the program was unclear. I'm just wondering if you have any updates on the future of Starliner, or if you think it'll come to an end at the completions, the missions you're under contract for with NASA. And just sort of wondering that, as Jim Freed said at the beginning of the call, as others have said in the past, the importance of having, redundancy in the Commercial Crew Program. Thanks.
So the focus, again, is on CFT. It really is all of our attention at this point. We have made some decisions in the last several months on the launch vehicle and making sure that we have enough launch vehicles to get us through We're on contract for 6 flights of ATP for the first 3, and we'll work on ATP probably this summer for 4 through 6. That carries us out to the end of the decade. And so we've got plenty of time to think about what's after that, and we will do that, but right now the focus is on CFT.
Thanks for your question, Chris. We'll move on to our next question from Marcia Dunn from the AP. Please do indicate, as Chris did, who you're directing your question to.
Yes, again for Mr. Nappi, please. How critical is it for Boeing to score a win with this Starliner flight? And given everything that's happening on the airline side of the house, is the pressure on more than ever to get this one right? Thanks.
So I really focus in on the program. And the success of this mission has always been very important for us as a program for a lot of reasons. Number one, we have humans flying on this vehicle. We take that so seriously in human space flight. I've spent my career in this business, and it always has been the top of the list. Second is this is an important capability for NASA. And so, we signed up to go do this, and we're going to go do it and be successful at it. So, I don't think of it in terms of, what's important for Boeing as much as I think of it as in terms of what's important for this program, what's important to follow through with the commitments that we made to our customer.
And I'd like to add something, if I may. I work side by side with Mark and the Boeing team every day, and so what I see from them is what I've seen for the 37 years that I've worked in human spaceflight. It's really the dedication, the persistence, the perseverance to take it step by step to get the vehicle ready to go fly. And when I say the vehicle, I'm talking about the spacecraft, to work with United Launch Alliance to get the rocket ready to go, to make sure that the flight software is ready to go, make sure that the crew training is in place, make sure all the certification products are done, all the analysis is complete, double-checking things when we need to. So I see a total focus on this mission and making it successful from the way that we always have done human spaceflight in my time at NASA, whether it be in shuttle or the Commercial Crew Program. It's really just taking it step by step, methodically getting to flight. We went to the FRR today and we took that step, and now we're going to close out a few more things. We have every flight that I've worked on, there's a sort of a punch list of things that we have to get done in a certain order, and that's sort of what we're about. The NASA team and Boeing team working side by side.
Thank you both. We'll move on to the next question from Joey Roulette of Reuters.
Hey, thanks. 2 quick ones for Steve and Dana. Mark kind of went into a pre-launch to-do list in the next few days, but what closeout work and pending issues remain, Steve, as you mentioned, and did Boeing request any variances or any kind of higher risks for this, and if so, what were those? And for Dana, can you confirm that the international partners gave the green light for Starliner to visit the station? How did those discussions go? And then quickly for Emily, as Marcia said before, this mission does come in a time where Boeing is still struggling with production issues and problems in the aviation business. And while that is a separate unit, it's the same company. And I'm just curious how NASA kind of makes sense of that, what kind of oversight they might have wanted to beef up on the Starliner side, or how the astronauts kind of view that in broad terms. Thanks.
Okay, there were a lot of questions there. Let me see if I can get at least a first couple of them. On the NASA side, literally we have really a couple things that we're working on. One of them is at the ULA launch pad, Complex 41. There was a valve that we needed to swap out. It's on the system that provides what I would call replenishment of the liquid oxygen. Once the vehicle, the first stage is tanked with liquid oxygen, and so that valve is being swapped out. Our teams are following that closely, and that's one item that we have to get through to be ready to go launch. And then the second one was, I would say, as an abundance of caution, going back and looking at the way our parachute system on Starliner works is there's a forward heat shield, much like Orion, that comes off. There was 2 small parachutes that pull that forward heat shield off, and that exposes the drogue parachutes to be able to deploy. we want to go back and look at some of the contingency cases. If one of those two for heat shield parachutes doesn't deploy, we want to go back and double check that analysis one more time with the latest trajectory, the latest vehicle, latest mass properties, and the center of gravity. So we're going to go do that. So those are really the two big things that I say we have in work. But other than that, we have closed out the certification. You asked a question about variances. There are a number of variances that were submitted by the Boeing NULA team. We've approved all those. There's none of those that are open at this time. I would say, just talking about the overall certification, let's just talk about the abort system on Starliner as one. This vehicle has a tremendous capability to abort. We have a stringent requirement. We break the trajectory down from launch all the way to orbit insertion in 10-second bends, and we say that 95% of those cases that we run an analysis with in any one of those bends needs to be successful. And so we've looked at all the abort data for every one of those 10-second bends, and those all are within our requirements for the entire launch trajectory. And there's about 4 or 5 different abort modes. So we've gone through that certification and approved all that work. So that's just one example. The parachute systems, we've approved the certification of that. That's hugely important for Orion as well. They fly the same parachute system, a derivative of the same system that we're flying. The NASA docking system will be used as a derivative for Orion as well. There's a Block 2 configuration, so we'll be testing that on this flight as well. So I think those were the 2 questions that I had, and I'll turn it over to Dana for the next several.
Let's see, in terms of the international partners today, their poll was based on their readiness to accept the CFT Starliner to ISS. And they all polled go, no issues with that. Their future readiness will cover their go for flying crew. So that's by intention. So they'll do that as part of the run-up to Starliner 1 is when we'll get their go and readiness for flying their actual crew on the vehicle. And I'll hand it to Emily.
Yeah, and I would just note that our crew members and our mission control team have been working closely with this Boeing program throughout the spacecraft development, throughout the mission development. We've been step by step with them for a number of years as we've been through our previous test missions and as we've been planning how to best execute this test mission. As Butch said this afternoon, if we weren't ready, we wouldn't be here. We are really looking forward to getting the opportunity to to put this spacecraft through its paces. I'd also note that this isn't the only Boeing-built spacecraft we operate from Houston's Mission Control. We're looking forward to CFT, but we're also really proud to be operating the ISS, which is the longest continuously operational spacecraft in human history. So we're excited to bring the two together next week, and I'm just really excited for launch. Thank you all. I will remind the reporters on the line, there are a lot of you who want to ask a question, so please keep your question to 1 so that your colleagues have the opportunity to also ask a question. Next, we have Stephen Clark from Ars Technica.
Hi, thanks for taking my question. I think my question is for Steve Stich. Coming out of the FRR today, I was wondering if you happen to know the probabilities for loss of crew and loss of mission for the crew flight test, and if you also happen to know those same numbers for the most recent Crew Dragon mission. Thank you.
Yeah, that's a good question. I do have the loss of crew numbers in front of us, in front of me for Starliner. I don't have the Dragon ones in front of me, so I apologize. We can get those for you. But for Starliner, we approved this data, this verification a number of years ago. The requirement is to meet a 1 in 270 loss of crew, and Boeing exceeds that number with a 1 in 295 loss of crew number. And then the loss of mission is 1 in 55 is the requirement, and Boeing exceeds that with a 1 in 57 loss of mission. So, and I apologize for not having the Dragon data with me at this time. So
we can get back to you on that, Stephen. Okay, next question comes from the Atlantic. Marina, go ahead.
Hi, questions for whoever wants to take them. Can you give us some more detail on that valve you're swapping out? What's wrong with it now that warrants a replacement? And when you do that heat shield analysis, is there something that you would see there that would make you stand down from the launch entirely? Thanks.
I'll talk about the valve. This is a valve in the, as I said, the liquid oxygen replenish system on the first stage of the Atlas. The valve, when they went and inspected the valve before flight, we found some particulate matter in the system, and so we wanted to go in and check the valve. We looked at the valve body itself, and so it warranted the replacement valve, which is in the system now. We're in the middle today and tomorrow of doing flows with that particular valve, and we'll check it out, and I suspect we'll get that working just fine for flight. So my experience with pad systems is this is the kind of thing that we often see at launch pads, and this is on the ground side. This is not on the flight vehicle side. So we see this at lots of different launch pads. We had similar kinds of problems in shuttle, and so we'll work through it and clear that. And then the last item, the second question, I think, was on the forward heat shield separation analysis. And I don't really see that being an issue that would hold us up for launch, but we'll look at the data and we'll make sure that we're good to go fly with both the normal configuration with both the parachutes pulling off that forward heat shield, and then we'll look at the cases for the one parachute case where it pulls a little bit asymmetrically, and then look at the clearances and the loads, and I think we'll work through that.
Thank you, Steve. Next, we have Gina Sinceri from ABC News.
We talked about during the briefings in Houston earlier what your test objectives would be for this, but are there anything on the wish list that you would add if you had time?
Yeah, we went through a pretty exhaustive process between the Boeing and NASA teams, working with the ISS program to come up with our list of flight test objectives or operational capabilities. Those are really in two categories, I'd say. One are things that are robust for Starliner testing capabilities on Starliner, such as we'll do a manual piloting demonstration when we get on the axis, what we call the V-bar, an approach to the space station during the rendezvous phase. We'll have the crew do some manual flying. They'll do some other demonstrations of maneuvering two different orientations during the flight as well. And then once we get to ISS, we're going to do a number of tests to meet all the requirements we need at ISS. We'll do a habitability assessment with Butch and Suni for 2 crew and extrapolate that to 4. And then we'll also do what we call a safe haven demonstration. We use this spacecraft as a lifeboat, and so we'll have Butch and Suni get in and close the hatch and demonstrate that capability. So we think we've thought through all the things that we need to do. The one good thing about the way we've laid out our flight program is we've got a lot of time in the summer. We work with Dana Weigel and the station program. So if we need to extend the flight, if we think of something that we want to do while we're docked, we can do that, and then bring Starliner back when it's the right time to do so. So we've set it up such that we can take our time, think through things, and if there's something we want to add during the flight, we can certainly do that.
Thank you. Okay, next up is Jeff Faust from Space News.
Good afternoon. A question probably for Dana. How late can you delay the SpaceX 30 departure and still have enough time to get through the port relocation and other activities to keep the May 6th date?
Some of that depends on the actual landing location of the SpaceX 30 cargo vehicle. So we got to undock and land, and in some cases you could end up with 30 hours depending upon what the landing opportunity is. After we land, we got to turn around. You know, the SpaceX team obviously is doing both the Dragon cargo vehicle landing, and they're also supporting the crew relocation for us. So we've got a little bit of spacing that we've got to consider. They're both on board between the activities to get the crew ready, but then also on the ground team. In terms of where the the final kind of critical path run-up is that's kind of the crew relocation and then the subsequent robotic activities to do the inspection and get all the robotic equipment back in the right place. We know we can do that relocation on May 2nd. We're looking closely at May 3rd. That probably works, but that's still something the team's trying to wring out in terms of critical path to the launch date.
Thank you. Next up is Will Robinson-Smith from Spaceflight Now.
Yes, hi. Thanks for taking our questions today. Follow-up on Jeff's, I suppose, to Dana Weigel. If, for whatever reasons, things shuffle a little to the right and the mission does slide off of the 6th, can you provide the next 2 or 3 launch opportunities, the dates and the times, and then the subsequent docking opportunities that would present? Thanks.
Yeah, this is Steve Stich. I can go ahead and take those. Right now, the way we have set the launch opportunities up, we have May 6th and 7th, and then the 10th and the 11th. We're on the range right now for the 5th and 6th, or the 6th and the 7th, I'm sorry, May 6th and 7th. Those are reserved. The backup date of the 10th, but the next good day would be the 11th. And each of those rendezvous are about 24 hours in length. So, for example, on May 6th, we launch at 10:34 p.m. Eastern, and we would dock on Wednesday, May 8th, at about 1:11 a.m. Eastern time. So we have that sequence set up, and we'll work with Dana and the team. You know, we just take it one step at a time, like we've talked about really this entire year with Manifest, right? So we're down to the final steps to get space station ready for Starliner. And so we'll work with SpaceX and get CRS-30 on dock when the weather's acceptable, and we'll lay out that timeline. We want to give the crew a little bit of time to rest in between, and then prep their suits and prep Dragon for that port relocate. In fact, today we're starting to check out some of the Dragon systems to make sure we're ready to go do that port relocate. So we'll just take it day by day, and we also want to give SpaceX a little bit of time because the Cargo Dragon and the Crew Dragons are very similar, and so we want to give SpaceX a little time after the CRS-30 landing just to make sure there's nothing that they see in that landing. So.
Thank you, Steve. We'll move on to Irene Klotz with Aviation Week.
Thanks, Stephanie. I think this is probably for Steve. What are the biggest risks for the loss of crew and the loss of mission? And for the mission requirement, does that entail the full minimum 8 days at the station, or would, if there's some issue and it needs to undock early, does that still fulfill the requirements for the crew flight test to move on to certification? Thanks.
Yeah, I should have prefaced my statement when I responded to the loss of crew requirement. That requirement is for a full 210-day mission, right? So that loss of crew. So it is dominated by a couple things. One is MMOD risk. That's probably the biggest risk. It's about a quarter, let's just say, of that overall risk is MMOD. Obviously, that MMOD risk would be dramatically reduced for this very short duration mission. And then the next kinds of things that you get into really are the parachute system. Obviously, just by the nature of the way the pyrotechnic systems deploy that, that's a high risk system. And then, you know, other than that, I would say the separation systems are the next sort of highest risk. I think we would want to talk if we had a shortened mission duration. We don't expect to have that for CFT, but we really have a series of objectives we want to get executed. And I think we'd have to look specifically at what we achieved during the mission if we had a short mission duration at all. But the good news is what we're planning for is this 8 days, which is about the shortest time we can get everything done. We really have set up the whole timeline and the space station mission flow such that we have more days. So we'll step through the flight. Hopefully we get launched and docked, and then we'll take it one day at a time relative to getting all the objectives we would like to achieve.
Okay, thanks for that. Okay, next question is Bill Harwood for CBS News.
Hey, thank you very much. A real quick one from me, kind of the opposite of what Irene just asked. From a consumable standpoint, you've mentioned several times you got a lot of time to play with in this mission, but how long could Starliner stay up if you really had seriously bad weather at the end of the mission, got delayed getting there in the first place? But what is the max mission duration you could support on a flight like this? Realize you don't want to do that, but how long could you stay up? Thanks.
You know, on the station, we keep at least 4 months of contingency reserves on board of all different consumables. I probably got at least a month before I even get close to even my start of my 4-month line. So I've got tons of margin. The reason why we hold that type of a contingency reserve is just for that, whether it's resupply contingencies or anything we might encounter. And so just around the corner, at the end of the summer, I've also got resupply with the Northrop Grumman mission. So if we had to, we could go through the summer and then just resupply whatever we needed at the end of the summer. We dip into our reserves a little bit, but again, we intentionally build them up to give us enough capability so that we can handle a skip cycle or any number of contingencies. So really, I can't even imagine what type of anomaly or contingency we'd get into that keeps us up there that long, but we've got plenty of capability on board to keep the crew up there as long as we'd need to.
And for Starliner, I mean, we've been looking at various risks on Starliner. We've approved a risk on the crew module battery to stay up for 45 days. If we had to stay longer, I think we could look at that and extend that a little bit. So there's really not too many things on Starliner that would keep us from staying longer if we had to. I can't, as Dana said, I can't imagine why we would want to stay much longer than the 4 weeks or a month or so if we had to, but we're ready to support that if we need to.
Great. Thank you. Next question is Eric Berger from Ars Technica.
Hi, thanks very much for doing this. Question for Mark Nappi. You talked earlier about sort of you were focused on the Starliner program, and I was just wondering, you know, looking back over the last 10 years, what has been the most challenging aspect of delivering, you know, to reach this point? You know, was it some technical hurdle with this spacecraft? Was it, you know, working in a fixed price environment? Were there fiscal challenges? I'm just wondering sort of, you know, what you think was the biggest thing you guys really had to tackle as Boeing to deliver on this?
Let's see. I think, you know, design and development is hard, particularly with a human space vehicle. So, you know, there's a number of things that were surprises along the way that we had to overcome. And so I can't pick out any one that I would point to. You know, I would say, though, that, you know, it certainly made the team very, very strong. I'm very proud of how they have overcome every single issue that we've encountered and gotten us to this point. There may be some more in the future, so I think we've got plenty of practice to learn how to overcome these things, but I really can't point to any one thing. This is a typical design and development type of program, and we've done a good job of getting us to this point.
Thank you, Mark. Next question comes from Ryan Caton from NASASpaceflight.com.
Hi, thanks for taking my question. My question is probably more focused towards Mark, but if anyone else has a better answer, then please do go ahead. Has it been considered to repaint Starliner between each flight or just clean it up like Dragon, or will we continue to see more scorch marks and battle scars, if I should say, as the capsules fly? Because on an image that we released, we can see a big scorch mark from Calypso's flight. Thanks.
Yeah, the outside of the vehicle is really protected with a thermal protection blanket, and that's what you see, the little scorching. We did talk about replacing the blanket, and then we, you know, on second thought, that the blanket is still very functional and it kind of gives the vehicle character, so we decided to leave it on.
Okay, good insight. Next question, Ken Kramer, Space Up Close.
Hi, thank you for doing this. A lot of good information. My question is for Steve Stich and Mark Nappi, I think. So the problems that delayed it in the end were related to the replacement of that tape that was somewhat flammable and the soft links on the parachute. Can you tell us in some detail that discussion about these issues in the flight readiness review and how you cleared it for flight? Thanks.
So, these issues were discovered in July, or I guess the June timeframe or so, and it delayed us out of July. The teams jumped on both these issues very quickly, and really we spent the rest of the summer and the fall getting the solutions in place. For the tape, we replaced a good, close to 90%, probably upwards of 90% of the tape. I think I've quoted that we removed a mile of tape from the vehicle, and so that problem has been really mitigated. And so that's what we talked about in our review, was how we mitigated that problem and drove the risk down to a very acceptable level. On the parachutes, we had the soft link issue. That soft link was redesigned. We made a decision to go to the next configuration chute instead of using the new soft link with the chutes that we had for CFT. So we took an extra step to get the chutes ready, and that involved the drop test that was done in January. So again, we summarized the successful drop test, how the chute is meeting all of the safety requirements and all the design requirements. We talked about that in the FRR and got everybody up to speed with what the residual risk is with both those systems.
Thank you both. Next question comes from David Curley from Full Throttle.
Thanks very much. Steve Stich, we've talked a lot about parachutes. Mark just did a little bit. You did the most recent drop. There was a drop 4 years ago with the drogues on the heat shield. Is it because it's the new system? Is it a specific part of flight? Is it a board? Is it the chutes? Is it the heat shield? What exact, can you give us a little more detail of what you want to kind of go back through the data about?
Yeah, that's a good question. The drop test that Mark talked about was really to test the design changes we made. There's an element called a soft link that we needed to redesign for both the drogues and the mains, which we tested in that test in January. We also beefed up one of the joints on the mains. There's 80 suspension lines that go down to collect to what we call the riser that then attaches to the spacecraft, and we beefed up the joint where that suspension line attaches to, I would say, the base of the canopy of the main parachute. So that was done in the test. What we really want to go back and look at here is an analysis that we did many years ago, and it was looking at there's a cover essentially that goes around the perimeter of the top of the spacecraft, and it's like a ring that comes off. That's the first component that comes off during the final parachute deploy sequence. So that comes off. There's two parachutes that pull that ring off. We just want to go back and double check an analysis that we did with those two parachutes. We're not worried about the parachute itself. We did a test, a forward heat shield test at a very high dynamic pressure, put a lot of load on that parachute, so we're not worried about the parachute. It's just a matter of that separation of that ring to make sure that it comes off cleanly with both the parachutes fully deflated and pulling it off, and then only one parachute. And so we just want to go back and double check that analysis, and that's what we're in the process of doing right now.
That's the 2020 test.
Say again?
That was the 2020 test? You did the balloon drop just on the drogues in the ring?
I'd have to go back and look at 2020, but it's not necessarily, this is not based on a parachute test. This is based on an analysis. So that the parachute test showed that that ring came off just fine and separated with no problem. What we really want to do here is look at all ranges of flights, both aborts, nominal, any kind of config we can get into, any orientation that the vehicle could fly in, and just make sure that SEP analysis is clean. So it is an analytical analysis that we want to do, looking at the flow fields in various configurations of Starliner, various aborts. So it's not necessarily related to that test. That test went fine in 2020. Every test we did with the forward heat shield attached, that separation performance was adequate and just fine. So.
Thanks, Steve.
Okay. Thank you.
Okay, thank you.
We'll move on to our next question from Lauren Grush from Bloomberg.
Hi, thank you for taking my question. I think this is for Mark. I know there's been a lot of focus on the recent flight issues, such as the soft links and the tape, but I'd love to know how confident Boeing is that it stayed vigilant about some of the other past flight issues, such as the software problems during OFT-1 and the valves. Thanks so much.
So one thing that we didn't talk about a lot was the work that's been done for over the last year that was unrelated to the things that delayed the flight. When we got more time, we spent more time working on and improving our flight software hardware interface. We did a lot of things with the crew and basically walked through the details of how our system works, made sure with the entire team that they were either satisfied on how the system works, or if we wanted to do more testing, which they did and we did, we would go off and do that and learn more and improve the system. And so over this last, it's been about a year, a little over a year, we've been really working hard on improving the flight software hardware interface, and we've incorporated several improvements to make the system, or have the system have more confidence in the system, I guess I can say. So there's been continued work done. We'll continue to do more work as we go to Starliner 1. And really, you know, there's continuous improvement never stops on this vehicle. We're going to learn as we fly in all of our systems, and we're going to incorporate the things that we learn and make improvements.
And we did share with the agency at the Flight Readiness Review, we had a topic on everything we've been doing on the flight software hardware integration. In fact, we reviewed, I suspect, Butch and Suni today. You could see their excitement when they came down here and landed at the shuttle landing facility. They talked about flying in the backup flight control mode, and we've added a capability to have some displays where they could manually fly in a contingency if they had to during entry and actually land the vehicle precisely at the field. We talked about that at the Flight Readiness Review as well. We talked about a lot of the work that we have been doing to improve the flight software and to test it in all kinds of regimes, including aborts. And so that was one of the topics that we went over today, to just let the agency know that it hasn't just been parachute soft links or P213 tape that we worked on for the last year. It's been really this continuous improvement process on the flight software and hardware integration. So.
Okay, thank you. We will move to our last question for today from David Deneau from About Space Today.
Well, thank you. And first, I'd like to echo what Jim said. It's phenomenal what everyone has done to get us to flight readiness. Mark, my question for you is this. Since the early days of America's space program, our astronauts have returned with a splashdown. We've seen the Soviets on land. What should the astronauts of Suni and Butch expect on this landing on Earth instead of the ocean?
So in OFT-1, we had a mannequin in the vehicle. I can't say anthropometric, so I won't try to say it. Rosie, yeah. And of course we had video inside the capsule as well. And I was very surprised by how soft the landing was when we watched the video. As the vehicle comes down, you know, we have a dual airbag system where the external airbags inflate. As soon as the vehicle touches down, they deflate and the inner airbags inflate, and it makes for a very soft landing. And when I watched the video, it's just a slight movement of Rosie inside in her seat, and so I expect that it'll be the same for Butch and Suni.
How fast would they return? What speed?
Boy, I'd have to get that. I don't have it off the top of my head, but we can get that for you. I mean, it's about equivalent to what we've been doing with the SpaceX Dragons, right? I mean, one system uses the water, I would say, as a cushion, the Dragon and Apollo and the other U.S. systems. And here, what we're doing is using an airbag, essentially like a shock absorber to cushion that landing at the end. So the parachutes slow you down to a certain sink rate, and then it's, use the airbags as the final cushion, and like Mark said, they deflate. And, but we can get that data for you. I just don't happen to have it off the top of my head.
Yeah, David, we can follow up with you on that. So that does conclude our time for today. Thank you to NASA's Jim Free, Ken Bowersox, Steve Stich, Dana Weigel, Emily Nelson, and Boeing's Mark Nappi, and to all of those who joined us and are listening today. We appreciate you spending the time with us. We appreciate your interest in the efforts of NASA and in commercial industry to expand access to space. You can learn more about NASA's Boeing Crew Flight Test online at nasa.gov. You can follow along at nasa.gov/commercialcrew, and we have a blog for regular updates on the mission as we get closer. That's at https://blogs.nasa.gov/commercialcrew. So please keep following along with the mission. We're all excited to see it launch, and go Starliner.